Hi, we are going to discuss the concept of clocks in this session. The movement of clocks has fascinated the young and the old alike for generations. Whosoever made the clock first should have been a genius. Yet, from a scientific perspective, it is a relatively simple application of the basic principle of time and distance. When we discussed time and distance, we talked about the applications being part of real life. This is a classic example of that. How is it that clocks form a classic example of time and distance? Well, the first part takes care of itself. Clocks are all about time. The second is slightly dicey. What is distance in clocks? Any place where there is a talk of distance, there is a movement of something from one place to another. Here, the hands of clocks move. So, there has to be some measure of distance embedded in those. The unit of distance, as we know, is meters, kilometers, centimeters, etc. But this is for straight line movements. What if it is rotation? It is still movement and therefore some distance is covered. The angular displacement is measured in degrees or radians, and that is the distance component of clocks. So here in clocks, distance is measured in degrees or radians and the time obviously in hours, minutes and seconds. I hope you've got a hang of why clocks are applications of time and distance problems. Now, let us analyze a clock. A clock is an instrument that is used to measure and show time. It has a round dial and has the ability to measure time in hours and minutes, and in most cases these days in seconds as well. There are markings for 12 hours. One day is 24 hours, and therefore the hour hand of the clock rotates across its dial twice in a day. The minute hand story is also known to us. An hour is divided into 60 minutes, and as there are 12 divisions in a clock, each division will correspond to 5 minutes. 60 divided by 12 equals 5. So, the number of minutes in an hour is divided into multiples of 5 as reference points in a clock. The minute hand at 5 will indicate 5 into 5 or 25 minutes after the hour. The minute hand at 8 will indicate 40 minutes past the hour. 5 into 8 equals 40. If the hour hand is between 5 and 6 and the minute hand is 2 minutes past 10 in the dial, the time will be 5. 10 into 5 plus 2 equal to 52 minutes, that is 52 minutes past 5. The second hand story is a little easier once you understand the working of the minute hand. The story is the same. Each minute is divided into 60 seconds. So, each of the division will point to 5 seconds. The second hand at 2 will indicate 10 seconds past the minute, and the second hand at 4 will indicate 4 into 5, that is equal to 20 seconds past the minute. Hour hand past 3, minute hand at 4 and moving, and second hand at 6 will indicate a time of 3 hours, 5 into 4 20 minutes and 6 into 5 30 seconds. So the time will be 3 hours, 20 minutes and 30 seconds. The hour hand shows the hour, minute hand shows the minutes as the indicator multiplied by 5, here 4 into 5, and the second hand indicates the time, that is a multiple of 5 of that indication. Here it is 6 into 5 equal to 30. Once we have recollected the basic logic behind clocks and timings, the need now is to look at its applications in any test. There are different types of questions in the clock set of questions. The most prominent ones amongst them are 1. The angle between the hands, and 2. The time taken to reach a particular angle between the two hands. To be sure of answering these questions, the relation between the angles in a clock and the movements of the hands need to be understood carefully. Let us do that now. A clock dial is a circle, and any circle, as we know, is 360 degrees in displacement. Understanding this is the most crucial aspect. Now, let us track the movement of the hour hand. The hour hand travels the whole dial in 12 hours. That is, it takes the hour hand 12 hours to travel 360 degrees. It is very evident when you look at the clock, is it not? There are inscriptions from 1 to 12 for time, and it takes the hour hand 12 long hours to get back to any specific point. This means that the time taken for the hour hand to travel 360 degrees is 12 hours. So, what is the speed of the hour hand? The speed is distance divided by time, that is 360 divided by 12 equals 30. What is 30? 30 degrees per hour is the speed of the hour hand, or in other words, the hour hand travels 30 degrees in 1 hour. 1 hour is 60 minutes, and therefore the hour hand will travel 30 degrees in 60 minutes, or the speed of the hour hand is 0.5 or half a degree in a minute. It means the hour hand will travel half a degree in a minute. This may not be evident to the naked eye, but the fact remains that the hour hand will keep moving every minute, howsoever minutely. So, it travels half a degree in a minute. Although the hour hand will move little by little as the seconds progress, there is minute deviations only that makes it negligible, and the speed of the hour hand is not expressed in terms of seconds unless that kind of minute calculations are to be done. The minute hand traverses the whole dial in 60 minutes. Look at the watch. By the time the hour hand moves from 2 to 3, the minute hand will move from 12 to 12. Is it not? Yes. So, the minute hand moves 360 degrees in 1 hour. So, what is the speed of the minute hand? It is 360 degrees per hour. An hour is 60 minutes, and therefore it moves 360 degrees in 60 minutes, and therefore its speed is 360 divided by 60, or 6 degrees per minute. In short, after every minute there is a displacement of 6 degrees for the minute hand. A minute is 60 seconds. The minute hand moves 6 degrees in a minute or 6 degrees in 60 seconds. So, the speed of the minute hand in seconds is 6 divided by 60 or 0.1 degrees per second. Look at the second hand. It moves the entire dial in every minute. Is it not? Yes, it does. So, it moves 360 degrees in 1 minute. So, the speed of the second hand is 360 degrees per minute. So, imagine the angle traversed in an hour. It speeds 60 times the dial in an hour. So, the speed per hour is 360 into 60 degrees per hour, that is 21,600 degrees per hour. It is another matter of fascination that any multiple of 360 will mean a circle and hence take it to the same place again and again. The second hand traverses 360 degrees in a minute, and a minute is 60 seconds. Therefore, it travels 360 degrees in 60 seconds or travels 6 degrees in 1 second. Therefore, the speed of the second hand is 6 degrees per second. Now that we've traveled the story of all the three hands of a clock, it is time for us to look at the pitfalls that may happen in measurement. 1. There are three types of units in the measurement of speed. 1. Based on hour, second based on minute, and third based on seconds. There is a fair chance that there is a mix-up between these units. It is to be avoided. Always use one of these three as the unit and stick to it. When in need of a change, convert only at the end and not in between. Second, there is a possibility of a confusion between the speeds of the various hands. Be ultra careful in the identification of the correct hand. These are the most common mistakes committed by the test participants as they attempt questions on clocks. So, try and avoid these mistakes in the initial stages of preparation itself. We are now clear of the basics. Now, let us try and solve a couple of typical problems based on clocks. Question 1. What is the angle between the two hands of a clock when the time is 4:20? There are three approaches to this question. Here is a note of caution. Learn one method and the others will naturally occur to you in course of time. Let us look at the first method. Imagine the time is 12 o'clock. This is the most important thing in the first method. The reference is always 12 o'clock. The assumption and the fact is that the movement of both the hands starts at 12 o'clock. Both the hands have traveled for 4 hours and 20 minutes and reached the position 4:20. The position of the hands at 4:20 is shown in the slide. Let us consider the hour hand first. What is the distance traveled by the hour hand in an hour? We know it is 30 degrees. So, what will be the distance traveled in 4 hours? It is 120 degrees. For time to be 4:20, the hour hand has to travel for 20 minutes more. Note that the hour hand does not move in spurts. It moves continuously. It moves every minute. What is its speed? Its speed is 0.5 degrees in a minute. So, in 20 minutes, it will move 20 into 0.5, that is equal to 10 degrees. So, totally in 4 hours and 20 minutes, the hour hand will move 120 degrees plus 10 degrees, that is equal to 130 degrees. Let us focus our attention on the minute hand now. We know after every hour it will come back to 12 or travel 360 degrees. So, it would have done that act 4 times in 4 hours and still be at the starting point at 4 o'clock. After that, it moves for 20 minutes. Do recollect that the speed of the minute hand is 6 degrees per minute. Therefore, it will travel 20 into 6, that is equal to 120 degrees in the 20 minutes. So, the total displacement of the minute hand in 20 minutes is 120 degrees. The hour hand has traveled 130 degrees and the minute hand has traveled 120 degrees. So, what will be the difference? It will be equal to 130 minus 120 degrees. That is equal to 10 degrees. And that will be the angle between the minute hand and the hour hand of the clock at 4:20. Note that here we have independently looked at the distances traveled by the two hands and found out the difference between the displacements to get the angle between the two hands. The second method to approach the same question is to look at the difference between the angles of the two hands at the previous hour and look at the travel of the two hands thereafter. See the figures given in the slide. The angle between the two hands at 4 o'clock is 120 degrees. 30 into 4 equals 120 degrees. We know that the angle between two consecutive divisions is 30 degrees in the clock. So, the angle between 12 and 4 is 4 into 30 equals 120 degrees. Now, the hour hand travels for 20 minutes and therefore will travel 20 into half degrees, that is equal to 10 degrees. And the minute hand will travel 20 minutes and therefore 20 into 6 equals 120 degrees. Remember that the speed of the hour hand is 0.5 degrees per minute and that of the minute hand is 6 degrees per minute. At 4 o'clock, the hour hand was ahead by 120 degrees. It travelled a further 10 degrees in the 20 minutes past 4 o'clock. The minute hand travelled 120 degrees in those 20 minutes. Now, what will be the difference between the two hands? The net displacement will be 120 plus 10 travelled by the hour hand minus 120 travelled by the minute hand, that is equal to 10 degrees. Now, we proceed to another method of analysis. Note that the need is to learn one method perfectly and then look at other methods. If they are not clear now, do not worry. They will get clearer in due course of time. The minute hand will travel 6 degrees in a minute, and the hour hand will travel half a degree in a minute. So, in a minute, the minute hand will travel 5.5 degrees more than the hour hand. At 4 o'clock, the hour hand is ahead of the minute hand by 120 degrees. This is the basis of this method. That is, get rooted to the hour previous to the time in question. In 20 minutes, the minute hand will travel 20 into 5.5, that is equal to 110 degrees more than the hour hand. The hour hand had a lead of 120 degrees, and the minute hand has made up 110 of those. Or the minute hand has reduced the lead by 110 degrees, just like a fast athlete gets closer to a slower athlete in a running race. Here, the hour hand is the slower athlete and the minute hand is the faster one. So, the minute hand tries to catch up with the hour hand. The minute hand has caught up with the hour hand by 110 degrees, and the lead now has reduced to 120 minus 110 equal to 10 degrees. Now, we've discussed three methods to approach the same problem. Ensure that you do not get confused looking at all the methods. Try to understand one method and slowly work on to the other methods. The moment you have your grasp on all the three methods, clocks will be a cakewalk for you. Now, refer the question Q2 for the second type of question. This question can also be attempted in many ways, but I'll show you only one method. When you do practice problems, you should try to answer those using different approaches. Once you can do that, you've become the lords of the clock magic or the clock logic. Moreover, it helps you to develop your overall sense of logic and aids general logic development by leaps and bounds by instilling in you the seeds of natural thought processes. Here is a word of caution. Never try and adjust your watch to find out the degrees between the minute hand, hour hand, or second hand, as you do not have the capacity to differentiate smaller angles. Here, the basis is 8 o'clock. Look at the figure. Here, the hour hand leads the minute hand by 8 into 30 equals 240 degrees. For both the hands to meet, the minute hand has to run 240 degrees more than the distance run by the hour hand. In other words, the minute hand has to make up 240 degrees of distance. In other words, the minute hand that runs faster should run and catch up with the hour hand, which is 240 degrees ahead of the minute hand. How much time will it take? We discussed a little earlier that every minute the hour hand travels half a degree and the minute hand travels 6 degrees. So, in every minute, the minute hand travels 5.5 degrees more than the hour hand, or the minute hand travels 5.5 degrees faster than the hour hand in a minute. The minute hand makes up 5.5 degrees with the hour hand every minute. So, to make up 240 degrees, the time taken will be 240 divided by 5.5, that is equal to 43.63 minutes. So, after 8 o'clock, it will take 43.63 minutes for the two hands to meet. So, the time at which both the hands of the clock will meet will be 43.63 minutes past 8. These two are the major types of questions on offer in clock's logic. However, different variants are available for these questions. One thing is sure. This logic is the only one behind all questions concerning the clock, and mastering the logic will ensure success in all questions under this logic. There are certain things to guard against though in clock logic. 1. Do not mix the different methods together. Get the answer with one logic and check the answer with the other methods. Slowly, all methods will become clear. Second, clearly understand the basics of all the methods. Everything else will fall in place. Do not leave a method completely simply because it feels difficult at the first place. Point number 3. The more number of methods with which you can get to the answer, the more the logic development. So, do not stop with the answer. Get to the answer with multiple methods. Fourth, the movement and the displacement of the hands form the core of the clock logic. So, ensure that it is very clear in your minds. There is no point in learning formulae without knowing the logic. You can easily be fooled if you know only the formulae. Once you understand the logic, you can look at any formula. Even if something goes wrong, you can get back with your knowledge of your basics. But if you know only formulae, then you will be left high and dry in case of obstacles. And finally, do not try to attempt clock questions by adjusting your watches. It is a sure short method to failure. Thank you and all the best.